All right, so in this video, we are going to be talking about solving literal equations. Please make sure you get the date on the top of your page. So what a literal equation is, it's basically a formula. It's an equation containing two or more variables. So some examples might include y equals mx plus b, the equation of a line. It might also include e equals mc squared. The formula for the slope of a line, y2 minus y1 over x2 minus x1. Those are all examples of literal equations. So our goal is to get just one variable with respect to the others, and we're actually going to do that using the same methods that we use to solve all equations. So for example, if I had A area equals length times width, and right now, this is solved for A. Maybe I want to solve for length. Maybe I want to know what the length of a rectangle is, not the area. Well, I would ask myself, what's happening to the length? It's being multiplied by W. So to get it by itself, I could divide both sides by W to isolate L to get L by itself. And W divided by W, that cancels out. So I can find out that the length of a rectangle is just its area divided by its width. But you guys know that. But this gives me an actual formula for it, which is really helpful to have in many cases. So let's do a couple examples. These first ones are going to be on the easier side. Here we're trying to isolate the variable by using inverse operations. So inverse operations are just things like addition and subtraction and multiplication and division. That's going to be pretty much what we're using here. So I'm trying to solve for r. I'm trying to isolate r. So to do that, I need to know, well, what's happening to r? It's being multiplied by t. So I'm going to divide both sides by t to get rid of the times t that's happening here. And so that leaves me with r equals d divided by t. I probably should have used s because you guys are used to seeing this formula, d equals st. All right, so the next one gets a little bit more complicated, but we got this. We're trying to isolate w. So sometimes a good strategy is to replace all the variables in the equation, other than the one you're solving for, with numbers. So let's say we had 10 equals 2w plus 6. If I were solving this for w, my first step would be to get rid of plus 6 by doing the inverse, which is subtract 6. So here, I'm going to do minus 2w to get rid of the plus 2w. Now, normally we would just say, oh, 10 minus 6 is 4, because they're like terms, so we can simplify it. P and negative 2L, though, they're not like terms, so I literally have to leave it P minus 2L. The plus 2L is gone on this side, and I'm left with 2W. So here, let's just, for fun, pretend we couldn't simplify 10 minus 6. What we would do next to get W by itself is we would divide both sides by 2 to get rid of the times 2. We'll do the same thing here. And so the times 2 cancels, and we find that the width of a rectangle is the perimeter minus 2 times the length divided by 2. Pretty much looks exactly like what we were doing here to solve for W. But now we just have a generic formula for the width of any rectangle. So we've got a couple of harder examples. And the reason these are harder is because we have parentheses. And so what I want us to do is anytime we see a times y minus x, so a variable outside of parentheses, I want us to realize that this is multiplication. So to get rid of it, instead of distributing, because sometimes distributing actually makes these problems harder, I'm going to divide both sides by a. So that gets rid of the times a in front. That actually gets rid of that. And so I'm left with h divided by a equals y minus x. And so now I need to isolate x by getting rid of this y. So to get rid of y, I subtract y, because y minus y cancels. And so I'm left with now, h divided by a minus y equals, this negative sign's still there, equals negative x. Now the problem is I don't want negative x. I want positive x. So to turn this positive, I have to multiply by negative 1. So I need to multiply this by negative 1 to make it negative h over a, this by negative 1 to make it plus y, and this by negative 1 to make it positive x. So I basically just flip all of the symbols in the equation so that I can be left with what x is equal to. Negative h divided by a plus y. So for this next one, this one's actually easier. Again, my first step is going to be division, but I'm trying to solve for a. So what I need to divide by is what a is being multiplied by. A is being multiplied by y minus x. I'm going to divide by y minus x here. That cancels it out on this side. A is equal to h divided by y minus x. Just like that, we can easily find a. So again, any problems with distribution in them, do not distribute. Just look at it as multiplication and divide. All right, so in these next ones, we're going to be dealing with fractions, which you already know I'm not a huge fan of. So I want to start by getting rid of them. The very first step is to clear the fraction. So for this first one, my denominator is 3. So my very first step is going to be to multiply by 3, which works out perfectly because that eliminates the fraction, and I'm left with 3v equals pi r squared h. Now these are all being multiplied together. So if I want h isolated, I need to divide by the two things it's being multiplied by. And I'm going to do that in one step. It just makes this process easier. So pi and r squared are gone. So h is 3 times the volume divided by pi times the radius squared. That's the formula for the height of any cone. All right, same thing here. We want to get rid of the fraction. So we're going to multiply both sides by b, which is great because now the denominator b is gone. So b times h equals m plus n. And if I'm solving for m, all I have to do is subtract n to isolate it. And so I get that m equals b h minus n. All right, let's try a couple more. So in these ones, we are going to be doing something that's called factoring. We're going to do a lot of this the second half of the year, so it'll be good to remember what the word factoring means. And essentially, it means undue distribution. So the problem with the first question is that v is in two places. We cannot solve for the variable if it's in two places. So we kind of need to ask ourselves, well, how did it get to be in two places in the first place? Basically, v had been distributed to 3 plus b. So off to the side here, I'm just going to look at that for a quick second. If I did v times 3 plus b, I would have to distribute the v to both terms. That would give me 3v plus bv, which is what I started with. So 3v plus bv is better written in this way because now the variable is in one place. So this is called factoring. Now, like we said before, instead of distributing, because that clearly made it more complicated, all I have to do is realize, oh, this is multiplication. So to get it by itself, I'm going to divide. 3 plus b divided by 3 plus b, that's gone. So v is equal to g divided by, and I know that looks like a 13, I'm so sorry, divided by 3 plus b. There we go. All right, so let's reverse distribute here, aka let's factor. So if we take r out, we're left with h plus b. And now, just division. So r is equal to 12 divided by h plus b. So these problems are actually really easy as long as you remember when the variable is in two terms to factor. All right, this last one you do not need to copy, so we're not going to copy this. I just want to talk you through it because you'll have a problem like this on your homework. So we're given the formula for the area of the triangle, A equals 1/2 BH. B is the base of the triangle, H is the height. So at first they want me to solve for B. So again, I'm noticing there's a fraction. So the very first thing I'm going to do is multiply both sides by the denominator of that fraction because that cancels it out. And from there, pretty easy problem to solve for B. We divide both sides by H. And so the base of a triangle, I'm like literally right now translating this equation into Mathanese. The base is equal to twice the area divided by the height. So here, they're giving us the area, they're giving us the height, they want to know the base. So the area is 192, the height is 12, so the base is twice the area. Oops, we know the area. Twice the area divided by the height. And I believe that gives us 32 as the base.